Let's look at this question. 8 friends, namely A, B, C, D, E, F, G, H, went to watch a movie. They were seated in the same row. It was observed that 3 people were sitting between B and D. A and H were sitting together. Exactly one person was sitting between E and F. Okay. And then we have the individual questions. Now, based off on this, simply look at B and D. If the 8 seats were numbered 1 to 8, 3 people were sitting between B and D. So for B and D, the probable spots that they could be sitting at would be 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Of course, B could be at the latter spots also, D could be at the initial spots also. Both those cases are taken care of. A and H were together. So if A and H are together, the spots they could be sitting at are 1, 2, 2, 3, and 3, 4, 5, 6, 7, 4, 5, 6, 7, and 8. And then exactly one person was sitting between E and F. So EF 1, 3, 2, 4, 3, 5, 6, 7, 8, 4, 6, 5, 7, and 6, 8. These are the possible combination of seats that these three groups of people can be sitting at. For G and C, we have no additional information. First question, if G and C were sitting on extreme ends, in how many ways can they all be made to sit? Okay, so 1, 2, 3, 4, 5, 6, 7, and 8. G and C are sitting at extreme ends. So G is here, C is here, C is here, G is here. For these two spots, we already know. Given that these two spots are already used up, can I go? These spots have now become unavailable for people. These spots have now become unavailable for people because 1 and 8 have been already used up. Okay. So now let me place B and D somewhere. Let me place B and D at 2 and 6. So B and D 2, 6, and D slash B. I can make them sit this way. Okay. Now, once I've taken care of B and D, the next set of people I'm taking care of is E and F. Next set of people I'm taking care of is E and F, while ensuring I leave 2 consecutive seats. So if AH comes here, E and F can come here. If EH comes here, in the next two, let's say seat 1, 2, 3, 4, 5, 6, 7, and 8. If E and F come in 3 and 5, if A and H come in 3 and 4, if A and H come in 3 and 4, then E and F can come in 5 and 7. That is possible. If A and H come in 4 and 5, then E and F cannot come anywhere, which is to say there is only one possibility. There is only one possibility where A and H come here, H and A come here, E and F come here, F and E come here, and this entire case is made. Now, hopefully you remember our starting point for this case was BD sitting at 2, 6. So there has to be an alternate case. Let's say CG, CG. The other case I'm checking is 3, 7 for BD. So B slash D here and D slash B here. This also I've got. Now again, I have to leave 2 seats for AH, 2 consecutive seats for AH, and EF have to come at a seat that is separated by 1. Now 2 consecutive seats could be 4, 5 for AH. If they sit at 4, 5, E and F cannot come. So the only spots where A and H can sit are 5 and 6, A slash H, H slash A. Correspondingly, E slash F and F slash E. And this is done. And this is like the comprehensive list. This is like the comprehensive list. You cannot get any more cases with the condition that G and C are sitting at extremes. Now, in how many ways can they sit? See, for the top case, G and C can choose their seat in 2 ways. B and D can choose their seat in 2 ways. A and H can choose their seat in 2 ways. And D and F can choose their seat in 2 ways. Or altogether, for the top case, we get 16 sub cases. Similarly, for the cases at the bottom, we also get 16 sub cases. So altogether, in how many ways can they sit? They can sit in 32 ways. This is known. Now, for question 2, how many of the following statements must be true? Must be true. Now, when I'm looking for statements that must be true, even if I find one case where this is not true, that statement becomes invalid. So let's look at the first statement. If A and E are sitting together, A and E sitting together, so I can have A here, I can have E here, A and E are sitting together. As soon as locations of A and E are fixed, this is H and this is F is also fixed. Okay. Now, D and F will be sitting together. Not necessarily, I could have D at the second spot and B at the sixth spot. So D and F sitting together is not necessarily true. Okay. In one case itself, if I have disproven it, that statement becomes not necessarily true. Next case, if there is exactly one person between H and E. So that will only be possible if H is here, if E is here, which means A is here and F is here. If there is exactly one person between H and E, there must be exactly one person between B and A. So whether I put B here or whether I put B at spot 6 or at spot 2, can you see with A, there will always be one person in between. So I have not been able to disprove statement 2 with the first case. Let me look at the second case. A and E, sorry, one person between H and E can only happen if E is here and H is here. If H is here, A is here and F is here. Now, whether B comes at spot 3 or B comes at spot 7, there will again be exactly one person between B and A. So this statement is always true. This statement is always true. This is known to us. Okay. Now checking statement C and D. C now. There are two people between C and A. C is here, A being here, not possible. So the only way it works is if C is here and A is here. So that will mean H is here. That will mean G is here. There are two people between C and A. There must be two people between E and G. Not necessarily. I can have E at spot 7 also now. I can have E at spot 7. So this statement is not necessarily true. Next, if C and D are sitting together. A minute. Let me get rid of C is here, D is here. If D is here, B is here, and G is here. If C and D are sitting together, B and G must be sitting together. No, B and G are not sitting together. They are separated by one person. So this is also not necessarily true. So of these four statements, the one that must be true is only of statement B. And therefore, the answer to the question is A1. Okay. Next. It was observed that exactly two persons were sitting between G and C. Exactly two persons were sitting between G and C, which means the cases that we have generated so far are no longer valid. So I'm getting rid of all these cases. It was observed that exactly two persons were sitting between G and C. So G, C. Two persons between them means 1, 4, 5, 6, 7, and 8. 2, 5, 3, 6, 4, 7, and 5, 8. These are the possibilities for GC. Okay. It was also observed that neither A nor H was sitting at any of the extreme ends, which means this is no longer possible. This is no longer possible. I have to get rid of this cross. A and H cannot be sitting at either ends. How many of the following statements can be true? Can be true. Okay. The difference between question 3 and question 2 of the set is question 2 says must be true. So it has to be true in every case. Question 3 says can be true. So even if it is true in one case, that statement becomes valid. Okay. Let us try to create cases here. 1, 2, 3, 4, 5, 6, 7, and 8. I will start off with BD. B is here, D is here, 1 and 5, B here, D here. This is done. Now I need to place AH in two consecutive sets. AH in two consecutive seats. Or if I need GC, first I will try to place GC. Now that 1, 5 is gone, now that this case is gone, I will, for this case, 1, 5, this is removed, 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 this is removed. These options are no longer available. These options are no longer available. Okay. So I will try to generate for AH if I put it at 2, 3. AH and AH. So if they take up 2, 3, 2, 4 is gone from here and 3, 6 is gone from here. 2, 4 is gone, 3, 6 is gone. How do I place GC? Can I now place GC anywhere? GC here, GC here. Yes, there is one possibility. If G or C come here, C or G come here, and correspondingly E and F come here, F and E come here. This is an acceptable case where AH is not at the boundary. AH is not at the boundary. AH is placed on spot 2 and spot 3. But then this is not the end of checking for this case. This is not the end of checking for this case, because now I can also put, let's say if I put AH here, B slash D is here, B slash D is here. Can you see for this becomes an unacceptable case right away, because between EF there is one person, between GC there is two persons. I cannot possibly fill up these two spots because there are the three spots between them are used up. So AH at 3, 4 wouldn't work. In the same vein, if I try to put AH here and AH here, again between spot 4 and spot 8, there are 3 people already filled up. EF needs only one person between them and GC needs 2 people between them. These 2 spots cannot be filled up logically. So this is also an unacceptable case. And there are no more cases left for us to check. There are no more cases left for us to check for AH, which means this is the end of all possibilities for BD sitting at 1, 5. This is the end of all possibilities for BD sitting at 1, 5. Okay. Now we have to make new cases again. 1, 2, 3, 4, 5, 6, 7, and 8. Let BD be seated at 2, 6, 2. BD and BD. Now AH, if it comes at spot 3 and 4, again these 3 spots may get used up, which would lead to EF and GC not having any spot to use. Or if AH come at spot 4 and 5, then again these 3 consecutive spots get filled up, which is unacceptable because EF and GC will not have anything to fill up. Which is to say, there is no spot left for AH to come. If there is no spot left for AH to come, no case can be generated here at all. So this is also what you cannot possibly have a case with 2, 6 of BD. Let's have a case for B here, D here, and B here, and D here. Okay. Again, try to fill up AH. If I put AH at spot 4 and 5, in these 3 spots, again EF and GC, these 2 spots will necessarily have 3 people between them. Cannot possibly be filled up. It is impossible. Or if AH is at spot 5 and spot 6, then these 3 spots are filled up. EF and GC can't come. This is also unacceptable. We can't create a case at all. So this is also an unacceptable case, which means this is also gone. So the only case left is for us to check BD at spot 4 and 8. B here, D here, B here, D here. Okay. If AH can't come in 1, 2, if I put AH here, These three spots will be filled up. If I put AH at spot 2 and spot 3, AHBD, three spots are filled up. So 1 and 5 will be a problem again. Can't be filled up. This is unacceptable. Similarly, AH here will be a problem. AH here will be a problem because now spot 3 and spot 7 will have three people in between them. We can't have that. So the only spot where AH can come is spot 6 and 7. You have it at this way. We're checking for 4, 8. The only spot where A and H can come are these two. Now, if I have to fill up GC, it can only be done this way. And EFR left for E or F, F or E. Now, hopefully, even in the previous case and even here, hopefully you can see, look at all the filling up of seats from here and here. You will see they are identical. You will see that cases from, when you're placing these people from left to right or right to left, they are identical. So as soon as the top case was created, you could have happily gone on to say the bottom case is also created. But in case that doesn't trigger, you can also go ahead and check it out this way. It would be fine. Now, we have both these cases. We again have 32 cases identified. We again have 32 cases identified. For each of these 32 cases, we have to check. Let's see. First question. If G, see, for this question, it was which of the can be true. So we simply have to find one case where this is true. As soon as there is one case where this is true, our work is done. Okay. If G and D are sitting together. So in the first case, I'm looking, G is here, D is here. If G and D are sitting here, then this is C, this is B. There will be two people between H and E. Can I have two people between H and E? If I place H here and I place E here, so yes, this can be true. If G and D are sitting together, there will be two people between H and E. H here and E here, this can be true. So this is a valid statement, should be counted. Okay. Next case, if D and E are sitting together. So I have D here, I have E here, I have F here, I have B here. D and E are sitting together, there will be one person between B and H. I can have H here. Yes, this is possible. There will be one person between B and H. This is indeed possible. So statement B is also valid. Now statement C. If D and C are sitting together, D is here, C is here, which would mean B is here and G is here. Okay. There will be three persons between B and G. No, here I cannot possibly have three persons between B and G. There is no way this is true in first case. But right now we don't say this is untrue because it is not true in first case. We also have to check for the second case. Let's see what was the next thing. D and C are together. The only way D and C are together is if this is D, this is C, which would mean this is B and this is G. Can you see? They are separated by 5 people again. When it says 3 persons between B and G, this is never true. This statement is not to be counted. Okay. Now, the other storyline. If E and C are sitting together, E and C are sitting together, the only way it would work in the top case is E is here, C is here. If E is here, C is here, there is F here, there is G here. If E and C are sitting together, there will be one person between B and G. Now see, either B will be here when there are 0 persons between B and G, or B will be here when there are 2 persons between B and G. So not true in the first case. In the second case, let us try to work it out. If this is C, this is E, this is F, this is G. Now, E and C are sitting together. There will be one person between B and G. Either BG will be adjacent to each other, so 0 persons between them. Spot 4 and spot 5 will be BG, or spot 8 and spot 5 will be G. So there will be 2 persons between them. So one person between them can never happen. This is also not valid. So of the 4 statements, exactly 2 statements are valid. So answer should be option C. Now, the last question. Let X denote the number of people sitting between B and G. Okay. If for value of X, Let X denote the number of people sitting between B and G. And Y denote the number of people sitting between C and A. How many different values exist for X plus Y? Use data from the third question of this set. Third question of this set is simply G and C are sitting separated by two seats. So these two cases are still to be counted. So for the first one, how many people could be sitting between B and G? How many people could be sitting between B and G? So if B is here, G is here. I could have B, G, which would lead to D here, which would lead to C here. Okay. I could have it this way. I could also have it this way. I could also have it this way. These are the four possibilities for gaps between B and G. In this case, the gap between B and G is 2. Number of people, X could be 2. Or here, in the second case, X could be 0. In the third case, X could be 1 and 7. So 1, 2, 3, 4, 5. It could also be 5. And in the last case, there could be one person between them. So X can assume these four different values. Now Y denote the number of people sitting between C and A. Now depending upon C and A, where can C and A sit? See, in the first case, C is already fixed. C is already fixed. In the first case, or in all four cases, C is already fixed because as soon as G is fixed, C is already fixed. So I could have A here, or I could have, what have I done? I had, for the first case I'm working now. So ideally it should be in red so that confusion doesn't occur. But then I'm working here. I'm working from here. Now A could be here or A could be here. So number of people between A and C could be 1, 2, 3, 4 or 1, 2, 3. So either 4 or 3. Even in the second case, it is going to be either 4 or 3. In the third case, it could be 1 or 0. And in the fourth case, again, it will be 1 or 0. So the different values for X plus Y, how many different values exist for X plus Y? We're doing it for the first case only. We get 6, we get 5, we get 4, we get 3. This 6 we ignore, 5 plus 1, 6 we ignore because we already have a 2 plus 4, 6. 5 plus 0 we ignore. 5 plus 0 we ignore because we already have a 5 available from 2 plus 3. Then 1, 1 gives me 2 and 1 plus 0 gives me 1. So these could be the different values for X and Y, X plus Y based on the first case. Based on the first case, these could be the values for X plus Y. Okay. Now, based on the second case, let us try to figure it out for the second case. Hopefully, if you understand, left to right and right to left is the same, we will get the same values. But then let's see. I can have B here and D here and D here, D here, G here, C here, C here, G here, D here, B here, D here, D here, G here, C here, C here, G here. People between B and G could either be, again, could either be 2 or 5. Here it could be 0 or 1. Now that C is fixed, we can also look at A's, what all possible values. A could be either 3 people away or 4 people away. 3 people away or 4 people away. Now C and A, it could either be 0 people away or one person away. For B and G being absolutely next to each other, C and A could again be 3 people away or 4 people away, C and A. And finally, again, 0 away or 1 away. These are the different possibilities. If you look at the possible summations, we get 5, we already had that, 6, we already had that, 5, we already had that, 6, we already had that, 3, we already had that, 4, we already had that, 1, we already had that, 2, we already had that. This second case checking, now when we're checking, we're actually checking for the second case. In this, can you also see, we are not getting a new value at all. It is the same values that were generated earlier are coming on. So how many different values exist for x plus y? The answer is option A, 6, and that is the entirety of this set. Hopefully you learned something about data recording, which is the primary purpose of this set.